Let's look at continuity. In very simple terms, to draw the graph of a function, if we don't have to lift the pencil, then we say the function is continuous at all points. And at a particular point, we can say, since it is continuous at all points, we can say it is continuous at a particular point as well. But sometimes what happens, a function, to draw the function, we might have to lift the pencil. Okay, so we might go like this, and then we might have to go like this. So there is a jump here. So it is not continuous. But how do we describe it mathematically? Okay, let's say we have a function and we are interested in a particular interval or particular domain. Let's say the domain is a open interval, or f of x defined in an open interval. So within this open interval, we might be interested in a particular value of x. So that should be there consisting of x equal to a. Then three conditions have to be satisfied for the function to be continuous. F of a itself should exist. Second is limit as x approaches a of f of x exists. Now remember, here it may look like this, but remember, to really figure out whether the limit exists or not, we have to look at it from both the sides. So limit as x approaches a from the negative side of f of x is equal to limit as x approaches a from the positive side of f of x. They both should be equal for the limit itself to, okay. And then finally, limit as x approaches a, that is point number 2, what we looked at, of f of x is equal to f of a. So f of a itself should exist. Then left hand limit and the right hand limit should be equal, and the left hand side, right hand side limits and f of a should be equal. So in short, we can say limit as x approaches a from the negative side of f of x is equal to f of a, which is in turn equal to limit as x approaches a from the positive side of f of x. Okay, if this condition is satisfied, then we can say that the function is continuous at a. So let's look at some examples. Let's say f of x equal to sine x by x. So f of a itself should exist. That is first condition. So does f of 0, that is sine 0 by 0, does it exist? No, division by 0 is not allowed. So does not exist. So there is no point in going forward. Since this itself doesn't exist, there is no point in going forward to check the second condition and the third condition, and we can say that the function is not continuous at x equal to 0. Okay, let's look at the next one. F of x is equal to tan 3x by 3 if x is not equal to 0, and it is 1 if x is equal to 0. Let's take it step by step. Does f of, and we are interested in at x equal to 0. So does the f of 0 itself exist? Yes, it is equal to 1. Now, that is 1. Second is limit as x approaches 0 of f of x. See, till it is not equal to 0, it is something else, and in which case we have to evaluate tan 3x by 3. So let's say 1 if we take x equal to 1. Then what happens? Tan 3 by 3. Yes. So it will have some value. Will it be 1? And that's the question that has to be answered. Now, as far as the limit itself is concerned, if we go towards 0, the whole thing will become 0. Okay, so here itself it doesn't match. So it is not continuous. Let's look at the next one. F of x equal to ceiling. Now here what happens? F of, let's say 2, take any integer value. F of 2 is equal to what? It is 2. So f of a itself exists. Now limit as x approaches 2 from the negative side. Now this is equal to what? From the negative side means what? Say 1, 2. Negative side means from this side. So as we go closer and closer and closer, what will happen? In all these cases it will remain 2. So it is equal to 2. Now let's look at limit as x approaches 2 from the positive side of f of x equal to what? Let's say this is 3. This is 1, this is 2, this is 3. Now as we come closer and closer and closer and closer to 2, f of x will be what? It will be 3. Yes. So which means our third condition, that is limit as x approaches 2 of f of x equal to 2, which is not equal to limit as x approaches 2 from the positive side of f of x. So it is not continuous at x equal to 2, or for that matter at any multiple of or any integer value, n at x is equal to 1, where n belongs to okay. Now let's look at the next one. F of x equal to x square, where x is between 0 and 2. 2 plus x when x is greater than or equal to. So f of 2 exists, f of 2. So that means x equal to 2. So equal to 0 is less than or equal to x. Okay, x is equal to 2. Right. So if x is equal to 2, then it is 2 plus 2, 4. Right. Limit as x approaches 2 of x square. What is it? It is again 4. So which means the function is continuous at x equal to, we were to look at 2, not 0, at 2. Okay, f of x equal to x square, no, not x square, it's already done, pi minus x if x is less than or equal to 0, pi plus x if x is greater than 0 at x equal to 0. So f of a exists, which is equal to what? Pi. Limit as x approaches 0, f of x equal to what? As x approaches 0 from the left hand side, it is pi. From the left hand side. From the positive side, what happens? As x approaches 0 from the positive side, f of x, it is also equal to pi. So which means that this function is continuous at x equal to 0. Okay, let's look at another one. F of x equal to x sine 1 by x when x is not equal to 0, and 0 when x equal to 0. Now we are interested at x equal to 0. Now here what happens? F of 0, does it exist? Yes, it exists. No, it doesn't exist. Does not exist because 1 by 0 itself does not exist. Okay, but if we restrict our domain, right, if we say sine 1 by x, 1 by x is between -1 and 1. In that case, it is continuous. But then we are putting a restriction on its value. So you need to be careful about that. So here it is not discontinuous, it is not continuous. But if we put a restriction, then it becomes continuous at x equal to 0, of course. Okay, let's look at one slightly different type. F of x equal to x to the power of 5 minus 2 to the power of 5 by x minus 2 if x is not equal to 2, and it is k if x equal to 2. Now, at x equal to 2 is the point that we are interested in. Now what we have to do is we have to find the value of k for which it will be continuous. Now how do we figure out this? Now, if it has to be continuous, that means what? If it has to be continuous at x equal to a, that means limit as x approaches a of f of x should be equal to f of a, right? So which means k should be equal to f of 2. So which means limit as x approaches 2 of x to the power of 5 minus 2 to the power of 5 by x minus 2. Now you have to remember that there is a formula for this, or identity for this, or a standard limit for this. And the standard limit is what? 5 times 2 to the power of 4. Yes, it is x to the power of n minus a to the power of n by x minus a. Limit as x approaches a, right? This is equal to what? This is equal to n a to the power of n minus 1. So this is equal to 5 times 2 2's 4, 2's 8, 2's 16. 16 5's are 80. So suddenly when you encounter something like this, don't panic. Try to remember the various standard limits. Let's look at a different type of functions, or rather continuous functions, where you know that they are going to be functions. You don't even have to think about it, right? Look at a polynomial, right? F of x equal to, we know what it is, the standard way of writing it, plus a2x square dot 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 a n x n. Now there's nothing here in the denominator. So which means what? X can take any value, right? So since x belongs to real numbers, that means it is continuous everywhere. Now let's look at trigonometric functions. Now here what happens? F of x equal to some trig functions, sine, cos, right? Now as far as sine and cos are concerned, they are continuous functions. Why? Because for any real value of x, x belonging to reals, limit as x approaches a of f of x equal to sine a equal to f of a. So it is continuous. Now the moment you encounter a trigonometric function which has a denominator, right? Say tan x has a denominator, right? Sin x by cos x. Now cos x cannot be equal to 0. So there it creates a problem. Now in such a case, what you can do is you can define the domain. We can say r minus, we know the standard pi by 2, odd multiples of pi by 2. If we remove from the real numbers where n belongs to, so from the real numbers, if we remove these odd multiples, then tan x is continuous in that domain. So similarly, sec and cosec, which are 1 over cos and sine. So there also denominator is there. So if you restrict the domain or you specify the domain properly, then those functions are also continuous. Let's look at e to the power of x. Now here the domain is all real numbers. Log x. Here the domain is all positive real numbers. So they are continuous in their own domains. So a function is called a continuous function if f is continuous at every point of its domain. Okay, so which means polynomials, rational functions, trig functions, exponential functions, logarithmic functions are all continuous functions. That's enough for today. Bye for now. Please go to the about page of my channel, and here you will find various links for each topic. These are Excel workbooks which I have been using in many of my videos. Download it and practice.